Hello everyone. When an iron rod is heated to high temperatures, first it turns red. As the temperature keeps rising, it turns orange, yellow, and so on, and then finally white. Now, you may wonder, why doesn't yellow or orange come before red? Most importantly, why is light produced because of heating? Let us understand. We already know sound is produced because of vibration of particles. Now, light is also a wave, but it is an electromagnetic wave. It is produced because of vibration of charged particles or electric charge. Imagine these electromagnetic waves as the waves of ocean. There are peaks in the wave. The distance between two peaks is called its wavelength. The number of peaks that passes through a point at a given time is called its frequency. This means longer the wavelength, lesser the number of peaks that passes through a point per second. Hence, we can say longer wavelength means lower frequency. Now, we know that a rainbow has 7 colors. Each color of light has different wavelength. We know that red has the longest wavelength and low frequency, whereas violet has the lowest wavelength, which means it has the highest frequency. But wait a minute, here we are talking about visible light only. The range of frequency covering from violet to red is called visible spectrum. But the electromagnetic wave also has frequency outside this range too. To be more specific, the visible light is very small part of wide range of frequency in the electromagnetic wave. This entire range of wavelengths or frequency of electromagnetic radiation extending from gamma rays to the longest radio waves and including visible light is called electromagnetic spectrum. We already know Bohr's atomic model. Bohr proposed that electrons occupy stationary orbits of fixed energy at different distances from the nucleus. When we heat an object, electrons receive energy and move to higher energy state. And when an excited electron comes back to lower energy state, it radiates energy. His theory gives us basic idea of how light is produced because of heating, and it is because of that radiation of absorbed energy. You know, scientist Max Planck said that energy of electromagnetic radiation emitted or absorbed is product of H and F, where F is the frequency of the radiation and H is Planck's constant. Thus, Planck postulated that electromagnetic energy can be gained or lost in discrete values or quanta, not in continuous manner. The value of Planck's constant is 6.026 multiplied by 10 to the power minus 34 joule seconds. Looking at the formula delta E is equal to HF, we can easily say that less frequency means less energy. Hence, red color having lower frequency has lower energy than the blue color which has higher frequency. Thus, Planck's theory suggested that the energy of light is proportional to its frequency and also showed that light exists in discrete quanta of energy. So to sum up what we learned today, Planck's quantum theory of radiation. It states that electromagnetic energy can be gained or lost in discrete values or quanta, not in continuous manner. And we say energy emitted or absorbed is quantized. Also, the energy associated with each quantum is proportional to frequency. That is, delta E is equal to HF, where h is Planck's constant, and f is the frequency of radiation. That's all.